Hello everyone, welcome to CSE Core Concepts in my series of machine learning algorithms. In this video, I am going to demonstrate you about the KNN classifier algorithm, that is the K nearest neighbor algorithm. If you have missed my earlier video on the theoretical part of KNN, I suggest you to please go through that video so that you can easily understand the working of the KNN classifier and you will have no problem in understanding the implementation part. In my earlier video on the a priori algorithm with RStudio, I have explained to you what some of the small parameters about the RStudio and how you can get them installed and how to use it. So in my video, I am going to directly demonstrate about the KNN algorithm. Now, before moving on to the KNN algorithm, I would like to discuss about the dataset which I will be using here today. So here I am going to use a diabetes dataset. So in this, there are two classifications. Either the patient has diabetes or he does not have diabetes. To understand this, there are certain parameters. There are around 7 parameters: plasma, pressure, skin, test, mass, pedigree, and age. Based on all these parameters, it is decided whether he has diabetes or not. Okay. So there are around 768 records here. These are the training data. And as we have learnt in my earlier video, that KNN classifier is a lazy learner where it does not have any separate training phase. So whatever data we have, we will divide them into training and testing, of course, but we are going to put all of them together at once we will give it to the model. So let us get started with it. So first let us import the libraries which we require here. So for importing, the requirement of library file is library class. We require one library class here. And there is another library we will require here is caret. Caret library is used for classification and regression analysis. Okay. So let me just include these two libraries here. And it has been done. Okay, so class library, caret library. Class is there, and caret, it will help you to plot and everything, right? So let us read the data first of all. So reading the data. So how to read the data I have showed you. Let's take a data frame. My name of my data frame is diabetes data. It is a CSV file, so read.csv, and the location you have to put here about your data. Let's say diabetes.csv. Okay, so let me see. Yes, my data has been loaded. So on the right hand side in this video, here on this window, I can see that diabetes data is a data frame having 768 observations of 8 variables. Out of these 8 variables, 7 variables are what? Other variables. Okay, and the 8th variable is what? It is deciding, it is the class, right? It is the output. Let's see the structure of the data. So diabetes data, str, diabetes data, let's see. So you can see all of them are there. So plasma, it is of type integer, pressure is of type integer, skin is of type integer, and class is of type integer. Now this class I want to convert. I do not want to 1 and 0. Say I want to convert this information into either yes or no. So if the value is 0, I want to say that no. And if the value is yes, so I want to say if the value is 1, I want to say yes. So let's say converting. I want to convert to no and yes. Okay, so how will I do it is that diabetes data, okay, is which parameter I want to convert? Class. So you have to use this $sign and the variable name. So you can use diabetes data class, 1 minute. Yeah, class is equals to if it's 0, then you want to convert it into no. Okay, and similarly, if your data is class is, let's say, diabetes underscore data class is equals to 1, then it is yes. Okay, so after this, let us see the structure of the data. Diabetes data, has it changed or not? So yes, see, now you can see here class, it is of now type character having two values, either yes or no. So it will be easy for us to understand. Okay. So you can convert, still it is a character type. Okay. So I want to convert it into a categorical data type. So diabetes data, the class, I want to convert it into a categorical data type, that is factor. Okay. Factor, diabetes data class. Yes. So now again, if you want to see, yeah, so let's see. Yes, now it is a factor variable having two levels, either yes or no. I hope it is clear to you all what did we do here. Okay, we don't want a character data type. Now let us partition our data, partitioning. Let us partition our data into two parts, that is training and testing. Okay, so partition data is equals to the sample, whichever sample I have, I want to convert it into two parts. So the first argument is 2. The number of rows, which data I want to convert? The number of rows I have in the diabetes data, I want to convert it into two parts. Replacement, yes, it can be replaced with sample testing and training. And how much testing and how much training data you want, that you have to mention here. So let's say I want 70% training and 30% testing. What does it mean? Let's understand. See, out of your 100 records, you want to train by 70 records should be used for training and 30 records you want to do for testing. You can change this parameter. You can make it 80-20, you can make it 60-40, okay? Whatever is your wish, you can go for it. Not wish, actually, it depends on the model, how well your model is preparing. Suppose if you have kept 50-50. Now, if your model is not learning properly with 50 data, then your testing errors will be more, right? So more of testing training is required. So we have partitioned the data. So right hand side you can see partition data 1 to 768 rows has been partitioned. Now the first part, you want to make it train. The 70% data, you want to make it training data. So is equals to diabetes data. So partitioning data, first part of the data is your training data and the next part is your testing data, right? So diabetes data, which part? Part data is equals to 2, right? So first part is training, second part is testing. Wait 1 minute, some diabetes train data is equals to diabetes data partition part data is equals to 1. Yes, sorry, here there will be one comma, because whichever columns, all columns should belong, right? This is the first partition and all columns. So I'm not mentioning individual columns, but just a comma is enough. So now it is working. So right hand side you can see test data, train data is 530 observations. So out of 766 observation, 70%, that is 530, has gone to training sample and 238 has gone to testing sample. So now let us call the KNN classifier. KNN classifier. So my model which is getting created, I am giving it the name KNN predict. KNN is the class function name. So I have to pass what? Train data, right? Okay. Now it is a lazy learner. Everything has to be passed together, train and testing. Now for training, what you are going to do, all the columns have to be passed except the last one. Why? Eighth one you don't have to pass. That is the category, right? You don't have to pass that. That is not to be learnt. That is the output. So test data also -8 except the last column, and train data, what you have to train based on the class. But in KNN, you have to give a very important parameter, that is K. How many neighbors you want to include? Let's say 10. Okay, let's try with 10. Okay, so my model has been built. Fine. Let's see the model KNN underscore predict. Okay, so some model has been built and I am getting some answers. Now, how will I find out whether my answer is correct or not? So for that, we are going to create one matrix which is called as a confusion matrix. Understood? So, confusion matrix it is called. Now, this is a matrix which will tell you that how many data has been created correctly, predicted correctly. Let's say table. You are going to call table. Which table you are going to create based on the KNN prediction? Test data. Test data class. Okay, so you want to create the table based on the prediction made on the test data, and this prediction is done by which model? KNN underscore predict model. So my confusion matrix, let's see, it's very interesting to see the confusion matrix. So yeah, so now you can see this confusion matrix. Let me show you. It's very interesting. See, KNN, so there are 2 columns and 2 rows. So no, that means this is the actual and this is the predicted. Understood? So actually 132 is no and they are actually predicted as no. So it is correct. 31 are actually yes but predicted as no. Then 27 no and predicted yes, and 48. So you can see that diagonal values are the correct. So 132 are actually no and they are predicted as no. 48 are actually yes and predicted as yes. Understood? So rest of them are errors, wrong, right? So how do you find out the errors? So let's see the accuracy rate. How much accurate our model is? Accuracy rate. So to compute, how did you compute how many correct predictions I've done? First of all, you have to sum up all the values, right? And let's see, let's sum. Sum is equals to the diagonal. The diagonal values you want to sum of the confusion matrix divided by the total number of rows. N rows. How much total data you had? N row, right? Of which test data. So how many test data you had? Out of 238 data, how many have been correctly predicted? Only the diagonals. So 132 plus 48. Okay, so that has been correctly predicted. Let's see. Let's see the sum. So 55% for no and only 20% for yes. Okay. So confusion matrix we have called. So we can call it again like this: confusion matrix KNN predict, comma, test data class. You can directly call the confusion matrix function also. Okay, you can create the matrix using the table function also. Table of prediction of test classes, or you can have a directly function called confusion matrix which will create the confusion matrix for you. So here you can see many things have come. See, this is the predictions which are done and this is the reference or the actual. So no, actually there are 132 no's and 132 have been predicted, and 31 yes they are wrongly predicted as yes, actually they are no. 27 are actually yes but are predicted as no. 48 are actually yes and have been predicted as yes. So accuracy, how much you are getting? 0.75, that is 75%. CI means the confidence interval, that the model accuracy is ranging between 69% to 80%. Okay, p value. So ideal p value should be what? Less than 0.5. So what p-value we are getting? 0.009. So it is very good. Kappa is checking the accuracy with the random accuracy. So these are all the statistical different values which you can interpret. Okay. Now if you want to plot, let's see some plotting. Okay. So for that, let's say plot KNN. What I want to plot is the KNN model versus is being shown by this tiled sign. Okay, tiled sign, test data of class. Okay, so let's see some interesting plots. So here you can zoom and see the plots. So no, these are the test data class, which is actually no predicted as yes, yes predicted as no. Okay, so this is what is being seen. I hope you understood this video. Okay, you may try with some other data sets also. This is very interesting, and here you saw that since it is a lazy learner in one model only, we did not have a separate training phase. We passed the training and the testing data all together. Now you can check the model accuracy separately also. You can increase or decrease the number of neighbors. So you can see, you can recreate the model like this. You can check here. Let's see with the confusion matrix that how it is provided. Earlier we were getting some 75% accuracy, so the accuracy did not change as of now. Okay, even after increasing the number of neighbors. So you can increase and decrease and you can check it in this way. I hope it is clear to you. So in my next video, we will try to demonstrate the naive Bayes classifier algorithm. Thank you.